Well, welcome. I am Mr. Murphy, and in this lesson we're going to be looking at the second part of this lesson on transformations. Specifically in this lesson, we're going to start to combine some of the transformations that we saw in the previous video. So if you haven't had a chance to watch that, it's vital that you do so you understand what we're going to be talking about, what we're going to be doing in this lesson. So let's go ahead and get started with a warm-up. So I want you guys to see what you remember from the previous lessons. So why don't you go ahead and pause this video and work out these different, or describe in your own words what's happening with these different transformations. And so I want you guys to go ahead and pause the video now and hit play when you're ready to check to see if you did it correctly. All right, did you get to dust off those cobwebs and remember what you did yesterday in the previous video? Well, let's check. And so for this first one, where we have x plus 2 squared. Remember, anytime that we have something happening directly with the x, we're going to do the opposite of what we would expect. And so we're not going to say it moves to the right 2 units. Remember, it's in the form of x minus h. Whatever h is, that's going to be how the graph is affected horizontally. And since it's x plus 2, that told me that h is negative 2. Or we could just look at it as being, oh, the opposite of plus 2 would be minus 2, so it's going to be moving to the left 2 units. So that's how you would do the first one. Secondly, we have 2 times x. Again, something happening directly with the x there. So remember, we do the opposite of what we would expect. And so this is referring to horizontally. Is it being stretched or compressed? Well, since it's bigger than 1, and it's happening directly with the x, so again, opposite of what you'd expect, it's going to be half the size of what we would have expected. It's compressed to be half the size. And lastly, with letter C, x squared minus 2. So that minus 2 is happening after we square the x. So that tells me that this is going to be affecting the graph vertically. It's going to be a vertical translation. So we're going to say it translates down or shifts down 2 units. So that's a little warm up there. All right, so today in this video, we're just going to be looking at a couple of things. We're going to be looking at how we can look at what kind of transformations are happening from an equation. And sometimes we're going to have more than one transformation happening at a time. And then we're also going to be looking at a word problem and how to come up with a transformation from that. So let's look at what we've got going on today. Most of the times when we're dealing with graphs, we're going to be looking at specific equations like these. So what we're going to do is we're going to describe in words what's going to happen to each of these functions when we compare it to the parent function, which would be f of x equals x squared. So looking at that first one, again, we have 2 things going on there. So we have the negative out in front and the 1/3 inside the parentheses. So we can really describe it in any order, but let's start with the horizontally speaking. So the 1/3, that's happening directly with the x. So take the reciprocal of it, which would be 3. So this would be 3 times the size horizontally. So it's going to be stretched out to be 3 times the size horizontally. And the negative out in front means it's going to be flipped over the x-axis, or it's a reflection over the x-axis. That's how we can describe it. Let's look at the other one. The other one we have in parentheses x minus 4 quantity squared and plus 5. This one's going to be a little easier because this we don't have anything multiplied, we're just translating. But remember, we always, anytime that we have something going on specifically with the x, we always do the opposite. So the x minus 4, not moving to the left 4 units. It is moving to the right 4 units. And so we'd say it's moving to the right, or a translation of 4 units to the right and 5 units up. That's how you would do that one. All right, let's try these. So this one, it says, what transformations are happening to the parent function, this time dealing with the absolute value of x. So looking at that first one, we have 1/2 outside of the absolute value, and then we have x plus 3. So here's what that 1/2 means. That 1/2 means that it's going to be affected horizontally, okay, because it's not happening specifically with the x. So we would say that it's going to be compressed horizontally by a factor of 1/2, or it's going to be compressed to be 1/2 the size vertically. And the x plus 3, since that's happening specifically with the x, here we do the opposite with it, or the opposite of it. So we're going to say it moves to the left 3 units. So it's going to move to the left 3 units and going to be compressed to be half the size vertically. Okay, letter B, let's look at that example. Here we have the opposite value of x plus 2. So what that means is that it's going to be 2 units up, and then that negative outside of there means that it's going to be, again, flipped over the x-axis. So that's how you do those 2 examples. All right, lastly, we're going to look at how we can come up with an equation from a graph. Now, sometimes it's going to be a little easier, sometimes it's going to be a little harder. Now, it says here, So it gives a description there. A scenic train makes a trip on an old mining line. The graph shows the distance, y in kilometers, of the train from the station, x minutes after the ride begins. So x is representing your time. The y is representing the distance from the train station. So it's going to go to the mining station, or the mining line is going to go to the destination and then come back again. So we want an equation. Our ultimate goal is to come up with an equation for that line. So let's think about a couple of things first. So first off, what do you notice about the graph when compared to the parent function? So how do you notice how has it changed? What are some things that you recognize? So hopefully you should recognize at least 3 things. You should recognize that it's been flipped vertically over the x-axis. You should recognize that it's moved, that vertex is moved to the right 15 units, and it's also moved up 15 units. But, and so that, or let's start there. So it has been flipped over the x-axis and translated 15 units right and up 15 units. So we can come up with, for the time being, we can come up with a general equation. So looking something like this. And you might be saying, well, wait a minute. Why do we need that a there? Well, that a is going to represent how the graph might be compressed or shrunk at all. Okay, so we want to figure out, is there a value for a? Has it been stretched or shrunk? Now you might be able to look at that and determine that I really don't think it has. It looks like it's staying the same with having a slope of 1 basically. If you're to keep it as a v, I know it's been flipped, so it's be a -1 on one side and +1 on the other. But so you might recognize, well, the slope hasn't changed, so the a value hasn't changed. But maybe you don't know that. Let's figure out a way that you can determine that. So what you're going to do is you're just going to start by picking any point on the graph, any point. So I'm going to pick the point that'd be easiest. So for me, it's going to be 0, 0. And we're going to plug it into that equation, that general equation that we have right now. And again, the reason why, if you're wondering why we have x minus 15, is remember it moved to the right 15 units. So it'll be x minus 15. It moved up 15 units, so it'll be up 15. And the minus is because it's flipped vertically. So right now we're working on, is there a value for a? So if I put any coordinate from the line, I could use 15, 15. I could have used the point where x was 12, y was 12. I could have used a point where x is 24, y is 6. Any of these would work. I want to use something easy though. I'm lazy. So I'm going to use 0, 0. So if I put 0 in there for x and 0 in there for y, this is what we'd have. And now let's simplify the right side. If I take 0 minus 15, I get negative 15, but the absolute value of that is a positive 15. And negative a times 15 is negative 15a. Okay, so that's all in one step. Now I'm going to subtract 15 from both sides. And then lastly, I could divide by negative 15, and I would get a is 1. So what does that tell us? That tells us that there is no stretch, there is no compression here, because our a value is 1. If a was 2, well then we would just put 2 in the equation. Okay, so that's all we got to do. So going back to the original question, what equation represents the distance from the station as a function of time? This would be your equation. Y equals negative absolute value of x minus 15 plus 15. So there you have it. Putting it all together, what we've learned now into this lesson, onto a couple of examples here that we've looked at in this video. So good luck now as you work on your homework assignment.